Thank you very much. Actually, it's easy to get lost in that word big data, because I always say if I had $1 for every time I heard the word big data, I'd have a massive bankroll of money. But actually, that's not really what this talk is about. Actually, Eileen Naughton, in her opening statement, set up my talk like, they call it in the US, like throwing you a perfect big softball. At my age now, I can hit a big softball. Here's what she said. Consumers want personalized information, personalized products, and personalized selling. So that focuses on the most important thing for today's lecture or today's talk, the consumer. The consumer is the responsibility of the marketing function. A lot of people want to confuse you with 5 C's, 4 P's, segment, all kinds of stuff. If you're in a marketing role, you have one and only one responsibility at the firm, and that's to bring consumer insights to the firm that's going to allow your company to deliver better customized products and services. Now that leads to the next topic, which is big data. And as you can see by my title topic, as a matter of fact, I've actually given talks. I'm not going to do that today. I've actually given talks where I've actually stayed on the title slide the entire time. A lot of times the people that organize it get nervous. They're like, well, what about all those slides? I'm like, yeah, but it was going so well with the title. Why leave it? My title is meant to be provocative. Everybody talks about big data. Now let's say why they're talking about it. They're talking about big data because there's this belief if I have big data, I'm going to understand the consumer better, and therefore I'm going to be able to monetize against that. And my view is wrong. How would you like big, bad data? Anybody here? Raise your hand. Don't be ashamed. Anybody here want a lot of data that's so big you can't access it, and once you access it, it actually turns out to be awful data? Anybody want that big data? I'll give it to you right now for free. Anybody want that? No. You don't want big, bad data. You want better data. And that's what this talk is about. But let's again go back to the 30,000-foot view. Fundamentally, this talk is about understanding your consumer better. Each of your firms can understand your consumer better. And that involves, matter of fact, Tim, where's Tim, the first speaker? There's Tim. Tim said it the best. If people are spending 2.5 hours on touch devices, you got to be able to track that because that's better data. It's not about big data. It's about better data. So what I'm going to talk to you about for the next 30 minutes or so is a couple things. First of all, I want to convince you in the first 5 minutes why big data is the wrong way to think about it. Then I'm going to talk to you about how to solve the most important problem that faces, in my view, marketing today, and that's advertising attribution. It turns out solving the advertising attribution problem, like how much do you get from Google search versus Facebook ads, it's actually a trivial problem if you had the data. The problem is none of you have the data to actually answer that question, but it's actually a trivial problem. Then in the last 10 minutes of my talk, I'm going to give you some examples of really cool companies that are using the interface between technology and data capture to provide their customers unparalleled differentiation. And so if I had been giving this talk 10 years ago, do you know what, when I say differentiation, do you know what word I would have said? Segmentation. I hate to say it, but segmentation is kind of dead in Marketing Science 2016. You know why? Because why treat a group of people as homogeneous and the same when I can actually do, in a cost-effective way, one-to-one marketing today? I can do it if I have better data. So now you know everything I'm going to talk about, but hopefully I'll keep you engaged for the next 30 minutes as well. So again, look at the real title, Want to Understand Your Customer. I think if I asked for a show of hands, I think everybody in this room wants to understand their customer. And as I'm commenting on it, it's not about big data, it's about better data. And let me start with the following. Why is big data the wrong way to think about it? I don't know about you, but if someone hands me big data, and when I say big data, I just want to make sure we're all talking the same language. I'm talking about something like a petabyte of data or bigger, where you can't even load that data onto your machine. Forget about, maybe you don't even have a server that can handle that much data. And by the way, many companies today are generating data sets of this size. It's not hard. By the way, if you have 1 million customers doing 10 to 15 things a day, and you track that data set for about a year, you probably can't actually load that data set into any statistical software package that you can handle. So I always put this face up there. I've never thrown a party at my house when a company contacts me and says, Professor Bradlow, I got good news for you. And I'm like, great, I'm in the good news business. I love good news. And here's what they say to me, Professor Bradlow, we've got 10 petabytes of data we're ready to send to you right now because we know you build statistical models and do data mining. And I have to admit, it ain't that face, you get that face. I'm like, I hate to say it in the American vernacular, but holy shit, what am I going to do now? I don't know how to handle 10 petabytes of data, and even if I did, most of it's probably worthless. So first of all, big data is not going to solve any of your problems. And let me show you some examples why. As a statistician by training, the number one thing they teach you in statistics is what's called data compression. And when I say data compression, I mean the first thing anybody does, that anybody in business that I know of, when you're handling a massive data set, what's the first thing you do? You try to shrink it. But you don't want to be dumb and shrink it, you want to be smart and shrink that data. So it's just a very simple example of data compression, kind of the first example. This is the only mathematical formula. As a professor, you might think, oh, Professor Bradlow's going to come out here with all kinds of math. I assume everybody knows what the square root function is. That's the only mathematical equation I have here. But the square root of n is your friend. And here's what I mean. Imagine you have a data set where the rows are units or transactions. So imagine you're a website. Each row represents a different time someone comes to your site. It's a session. Imagine you're a retailer. It's every time there's a transaction. And imagine you measure that over time. Well, imagine you do the following. Imagine you take that data set and you do something that used to be well known as, it's called sampling. Imagine you take that big data set with 1 billion rows and you sample it down to 1 million rows. Well, just to give you an idea from the business perspective, if you have 1 million respondents, you can answer any business question with a precision of 0.1%, and if it's 1 billion, it's 0.0001%. Because things go down by the square root of n. You're cutting your data set by size 1 in 1,000, but you're not actually giving away that much information. I don't know anybody in this room that's going to get fired if they went to their boss and said, I got some news for you. People like our product, an 8 on a 1 to 10 scale, plus or minus 0.1%, and the manager goes, you're fired. I want to know the answer 0.00001%. Nobody wants to know the answer with that precision. So first, all you did was randomly sample your data, and you could do smarter things than random sampling, and you've already taken your data set from 1 billion rows to 1 million rows, and you're not fired. As a matter of fact, your manager's probably thanking you that he or she can take those 1 million rows and load them into whatever product you want to use. So first of all, don't forget about sampling. Second, getting rid of old data. This is actually a project I'm currently working on with one of my doctoral students. We actually have a big telecom company in Philadelphia, where I live, called Comcast. They're a cable provider. And I did a recent project for Comcast, and they go, Professor Bradlow, we got good news for you. I'm like, great. I just said I'm in the good news business. What is it? We have customer data back to like 1970. And I'm like, really? And they're like, yeah, isn't that good news? Look at all that data we have. And I said, are you kidding me? You actually think that data from pre-2005 has anything to do with the way people consume data today? You got to get rid of that old data. Now, here's the problem. When does data get old? And I hate to say it, that's why you need fancy statistical degrees like I have. I can tell you when data gets old by just observing the data. But the concept is very simple. People have this belief that from the time you acquire a customer until heaven on earth, you need to track everything about that customer forever. And the answer is, I've shown in some recent studies, you actually get the wrong answer because old data is telling you consumers behave like this, and they're not behaving like that anymore. So this is another way to take big data and make it smaller. Just get rid of that old useless data. That not only is it making the big data smaller, but the old data is telling you people, I'll go back to Tim's example, is telling you people consume in a certain way, but that was 2003. That might as well be a different century. It's so old. So the second advice I give you is track data, but when data gets old, you have to retire it. You don't want to use old data to make business decisions in 2016. The next one, Meta-analysis. This is my favorite math. I understand 1 + 1 = 2, but not in meta-analysis. So how many people have heard the term before, cloud computing? Cloud computing, everybody? Yeah, good. I see a lot of hands up. You know what the benefit is of cloud computing? I can take a data set with 1 billion rows, which I can't even load on my machine. I can break it up into 1,000 data sets, each of 1 million rows. I can send each of those 1 million rows to the cloud and do some analysis on them. I can do them in parallel. I don't happen to have 1,000 machines, but the cloud has a lot more than 1,000 machines. And now all of a sudden, that big data set that I couldn't even analyze because it was 1 billion rows, I'm now going to break it up into 1,000 analyses of 1 million rows each. The cloud can analyze. I can run my software, R, MATLAB, SAS, whatever it is, run it on the cloud, and get my answers back instantaneously. And not only has I've taken that billion-row data set and made it smaller, but I get probably why statisticians like me get the medium-sized paychecks, which is uncertainty. Notice, for each of those data sets, I could have put 1,000 on the screen, but the screen's not big enough. I get an answer data set by data set. Now I can see how much uncertainty there is in my answer, because I don't get one answer, which we call a point estimate, I get 1,000 answers. So now I can see how uncertain my answer is because I've broken it up into 1,000 smaller problems. So cloud computing is your best friend. You can take massive data sets, split it up, parallelize the computing, and now all of a sudden you have the potential. I know Google's going to talk about this at lunch, the idea of real-time answers. Cloud computing takes big data sets and allows you now to do real-time computing. And again, you don't lose that much by breaking up the data sets into small pieces. Okay? The next thing, statistical sufficiency and data compression. This is probably the thing I've spent the most time on over the last 5 years. Is the basic idea. Let's imagine we have 2 consumers. Let's call the one on top, and by the way, since I'm a professor, I have to give you a quiz, okay? But it's an easy quiz because there's only 2 answers. You have a 50% chance of being right, and there is a right answer, okay? Imagine the person on top. This is a timeline. Each of those X's represents a transaction by a given customer. And X represents when that transaction happened, and imagine the size of the X, although they're pretty much all the same size, represents the monetary value of that transaction. Which of those 2 customers, if I went to the right of that arrow in the future, do you think would actually have greater value to your firm? Customer A, the one on top who appears to be buying at a regularly spaced pattern, or B, the one on the bottom who appears to be clumpy in their pattern? How many people think A is more valuable to your firm? Okay. How many people think B? How many people have no idea whatsoever? Good, so we see some honest hands out here. It turns out the answer is B, and it's not even close. And this gets to the topic of what's called data compression. How many people here have ever heard the term, the acronym before RFM? You take your customer, you have a long history for a customer, but you don't want to store that long history. You want to keep 3 numbers about the customer. Recency, which is that little red arrow, how recently did they buy from you? Frequency, which is how many X's are up there. And M means when they buy, how much do they buy? For 40 years in marketing, people have been spouting RFM. Take your data, your big data, and compress it down to 3 numbers: recency, frequency, and monetary value. I just wrote a paper that got published in our most prestigious journal that shows it's wrong, and you need one more number. It's called clumpiness. I like to call it clumpiness. You might call it bingeability. It turns out customers who binge consume your content have a higher customer lifetime value in the future. And that's after conditioning on RFM, marketing spend, all the other things you might think drive future value. Clumpy customers come back. And when they come back, they buy an S-load of stuff. They come back and they act clumpy again. But this is an example where, imagine I have a massive data set, and all I have to do is compress it to 4 numbers: R, F, M, and C. That's a form of data compression. Now you've got a big data set that you've just made smaller, because I'm not just randomly keeping things about each customer. I'm keeping how recently did they buy, how frequently do they buy, how much do they spend when they buy, and how clumpy are they purchasing. So that's a smart way to think about data compression. So again, big data just became smaller. So I hope I've convinced you, whether it's through random sampling, getting rid of old data, parallelized computing, or what are called computing a set of sufficient statistics like RFM&C. It's a trivial problem to go from big data to small data. That's not what this talk is about, although I hope you learned something about how to go from big data to small data. Instead, I'm going to ask you a very simple question that's going to change your life. It's going to change your life. This question right here. How do you compute corporate profits? Anybody want to? This is not a trick question. I swear it's not a trick question. How do you compute corporate profits? I see Dominic. How do you compute I swear it's not a, just give the right answer. How do you compute corporate profits? But how do you compute profits, right? Revenue minus cost? How many, revenue minus cost, right? No. No. So I'm glad you didn't answer, because I would have said no. That's 19th century technology. And here I'm going to show you a mathematical equation that you will never forget. Yes, profits do equal revenue minus cost. But this is a product-centric way of thinking of things. Let me think of each of my products that I sell. Let me compute revenue minus cost, and I add it up. And that tells me how much money. That's true. But does everybody also realize it's the same as this? I compute revenue minus cost for each of my customers, and I add it up. You probably remember that from 8th grade mathematics. Whether you add up a set of numbers through the columns or the rows, you actually get the same number. But this changes your life, because you stop thinking about your products as being your profit centers, and you now start thinking about your customers as being your profit centers. Now, what are the implications of this? Well, first of all, it implies the right side equation, the black one, not the evil, bad red one. Customer lifetime value is king. Now your goal is to go after customers whose revenue minus cost is high. By the way, I'm sure everybody knows this. There are many customers that you serve for which their revenues do not outstrip their costs. And what should you do with those customers? You should fire them. You literally. Matter of fact, there was an interesting lawsuit recently brought in the United States. A company got rid of 100,000 customers. They said, we will not serve you. And there was a lawsuit. And actually the company won. You don't have a God-given right to get service from this company. So literally, if you have customers for whom revenue is less than cost, you should fire them. And this equation tells you why. The next thing is that you should rank order your customers. Some customers bring you more money than others. You should know which ones those are. Who are the high-value customers? And lastly, marketing is a simple problem. You just have to find the high-value customers and print millions of them. That's how you make money. So once you find out who the customer types are for which revenue minus cost is high, you literally could say, I'll make it up. They're men over the age of 45 that live in urban cities. By the way, that's me, okay? Just find the Eric Bradlows of the world, and I just got to find a million Eric Bradlows, and I got a massively profitable business. But let's get rid of all the 18 to 25-year-olds that live in urban cities that have no disposable income, so I'm not making any money from them. So the idea of thinking about your customers as your profit centers instead of your products will fundamentally change your business. But the only way to do that is to know your customer better, which is to collect better data. Okay? So again, the idea in 2016 and beyond, we're going from a marketing tool which says from mass marketing, everyone gets the same marketing, to segmentation, which means there are groups of people that get the same marketing, to what Eileen Naughton said this morning, which is one-to-one marketing. People want personalized experiences, and your responsibility as someone in marketing is to help your firm win profitable to deliver personalized experiences. So again, something I don't have a ton of time to talk about today is the one thing that used to be true but is becoming less true, it's not that cost efficient to treat each customer differently. So there's a big challenge, there's a big tension many firms face today. Like, am I really going to have 1 million versions of my website or 1 million different products or 10,000 different email campaigns? Probably not. But there's a sweet spot somewhere between I have 10 customer segments and I'm going to treat all 1 million of my customers the same. And part of our goal as marketers is to figure out where that optimal balance is. But again, I hate to say segmentation is dead, because if it's dead, I'm probably teaching our MBA students the wrong thing. But one-to-one marketing is a lot more alive than it used to be, because technology has enabled us to do it. And again, the driver of this is customer lifetime value. And of course, I've gone to the most important source to do that, which is Wikipedia. In marketing, customer lifetime value is a prediction of the net profit attributed to the future relationship with the customer. This should be your guiding principle from this point forward. Remember, profits are not the products, profits are the customers. I should find customers who have high customer lifetime value or predicted customer lifetime value, and I should print millions of them. That's what everyone should leave this room. Now, related to Tim's talk, how do you find these people? That's the challenge. And the problem is that the prediction problem, that red circle should be on prediction, that prediction problem is really, really hard. In the next couple minutes, I want to tell you why it's a hard problem, why it's hard to be a CMO today. I'm going to have another quiz. Can someone tell me what this is? Store scanner, right? No. You know, all my obvious questions, that's not the answer, right? This is what it is. It's actually a data collection device to help a chief marketing officer compute someone's customer lifetime value in the store. Because through this, every time Eric Bradlow goes to a store, I swipe my loyalty card, you know what products I've bought because of this, you can do it. Now you have a panel data structure where you can observe me over time. Now you know what coupons to give to me, and you can track how valuable a customer. So technology, the retailer thinks this is a scanner. I think this is a data collection device to help you compute customer lifetime value. Here's another question. What is this? A computer, right? No. It's a data collection device to help the chief marketing officer compute the customer lifetime value from your home or work. Because this tracks your web behavior. If I can know it's you, then all of a sudden I can see what websites you're going to. All of a sudden I can start thinking about your customer lifetime value. What is this? Right, it's not a phone. It's a data collection device to help the chief marketing officer compute your CLV out of home. What are you doing outside? And as Tim actually presented us some data with multi-homing, people are actually using this device in their home while sitting in front of a TV and in front of their actual laptop computers. Does anybody know what this is? So this is actually an eye tracking device where you can actually observe what someone's looking at. Now, I don't know if you know this, but in many retail stores today, it's not just about wearing goggles, which is one way to collect this data. Stores actually have these infrared scanners embedded in the shelving. So when you're standing in front of orange juice, they can know what your eyes are looking at. Now, if you think about the richness of that data, imagine I go to you and I say, imagine you're making orange juice for a living. That's what you guys manufacture. And I say, your sales don't stink because no one likes your product. People like your product, but when they go to the store, they don't look at it. And you're like, well, how do you know that? And I'm like, well, because I have eye tracking data that tells me where people's eyeballs are, and they're not looking at your product. So again, this is marketing in 2016. Imagine on a web page, Tim and Mike talked to us about web page design. Imagine I could know where it is you're looking on a web page. Well, you can actually today. You can know where someone's looking. So this is actually a data collection device to help the CMO understand what advertisements are being seen, the role of shelf space, etc. Okay? So, does anybody know what this is? It turns out most stores, probably about 20% of the stores in the US today, have little devices that have been attached to the bottom of supermarket carts that can actually physically track you around the store. So I know what path you've actually taken in the physical store, not just what you bought. In other words, I know how much time you spent looking at each product category. This is extremely valuable data. If you'd like, the goal of this is, we all know for the last 20 years or 15 years you can track people on the web, but imagine you can track people where they're located in physical stores. As a matter of fact, I don't have my phone on me. I left it at my desk there. Everybody here, I assume, knows whether it's British Telecom here or AT&T in the US, you know they know your geospatial location within a foot at every point in time. You know they're monetizing that data today, and you do know they have that data. They have your geospatial location at every point in time, and that data can be monetized. So just to give you an idea, 10 years ago, they didn't have that data. They'd say, do a survey. What stores do you visit today? Well, they know exactly where you are right now. Okay? So the important thing is the following. What is this? Now, these aren't the trick ones. These are loyalty cards, right? What's this? Oop. Let's see. I don't know. Oh, there we are. That's a registered user login. What's this? This is your IP address. What's this? Cookie tracking. The key to marketing in 2016, and actually both Tim and Mike talked about this briefly, I've got to be able to track you multi-channel across all the different places you go. So whether it's IP address tracking, I know the IP address of your computer, whether it's cookie tracking, whether it's loyalty card data, this is the key, because I need to be able to track all of these things integrated for every individual customer, because I need to have the full spectrum of all the things you're doing, and that's going to allow me to do better personalized marketing in 2016. As a matter of fact, here's a piece of advice for all of you. Matter of fact, here's how you know. Matter of fact, it relates to what Mike talked about in the Net Promoter Score. Here's how you know when your company has succeeded. When your customers willingly allow you to track them across every portal. As a matter of fact, they want to give you the data. Every time they go to your website, they want to scream, "It's Eric Bradlow." Every time they go to an app, "It's Eric Bradlow." Every time they go to the store, "Hey, it's me." Then you know your company has succeeded in true marketing, because then your customer is willingly giving you the data. You know why? Why would Eric Bradlow, me, why would I want to do that? Because I'm going to get better deals, better recommendations, better promotions, better marketing. I'm so engaged with the brand that I want to give them every piece of information, and every time I want to let them know it's me. Okay? So I just wanted to say, I'm not going to skip this one, I'm only going to spend 30 seconds on it. It actually turns out we did a study to try to understand the value of advertising attribution. We actually worked with a very large retailer of automobiles. And we had for a panel of 1,000 people, we had every piece of marketing that those people were exposed to. Which means if they went on email, they got an email, we knew it. If they actually watched TV ads, we knew it. If they went on websites, we knew it. We knew every integrated piece of marketing communication that was delivered to these 1,000 people. And it's only through that kind of data set, and eventually the person bought at the website, it's only through that kind of data set can you answer the hardest problem in marketing today, which is how much is Google search worth versus how much is a TV ad worth, etc. We actually collected this, and here's what we found. The first finding, and this part was shocking to me, digital advertising is much more effective than people initially thought. It turns out, while most people don't click on an ad and buy immediately, most people will click or observe the ad and buy downstream. It happens to be, everyone knows the term last click attribution. It's rare that display advertising is the last click. It tends to be earlier in the funnel, but it has a huge impact. The second one, which was shocking to us, is the market is efficient on pricing. What I mean by that is a TV ad might cost 1,000 times a banner ad, and you know what? It's roughly 1,000 times the cost. Turns out the market is very efficient in pricing different channels. Or if you'd like, gross rating points, which is the economics of advertising, is a pretty efficient mechanism. The last one, and I'm not just saying this, by the way, this slide is not tailored to Google, let me say. I'm supposed to be neutral like Switzerland. So us professors, we just call it like we see it. Turns out Google, of every firm in the world, should care most that last click attribution dies a fiery death. And that's because search is typically also not the last thing you do before buying a product. It tends to be early stage. What we found over and over again is search actually is very valuable for attribution, but it's rarely the last click. It almost gets shortchanged in attribution. So let me wrap up just with 3 quick examples. How many people here know Netflix? All right, good. See how great a job Netflix is doing? By the way, my favorite story is that the head of NBC Universal came to the Wharton School in May, 1,000 students in the room, and he asked those 1,000 students, how many of you watched the news in the last 24 hours on TV? Not one single hand went up. Not one out of 1,000. Not one. He asked all 1,000 of those people, how many of you have been on YouTube? Probably 80% of the hands went up. How many of you watched some content on Netflix? Probably 60% of the hands went up. So this is how Netflix is using better data. What Netflix is doing is every time you watch something on Netflix, they do what's called meta-tagging that content. For example, I love police shows that take place in the 1970s in California. I don't know why, but I do. I just do. I like police shows that take place in California. Maybe that's because I was a kid, although I grew up in the East Coast. Maybe because I was a kid in the 1970s, so I love police shows in the 1970s. Every time you watch a piece of content on Netflix, they're meta-tagging that content with characteristics. And here's the shocking part. They're actually using it to create new content. So you may know the show House of Cards. House of Cards was created based on a mathematical algorithm, based on people's viewing behavior and meta-tagging that content and coming up with the optimal show based on people's consumption behavior. This is a well-known problem that's been solved by statisticians for years, and the reason Netflix could come up with a hit show was because they understood about better data. They understood if we just take the data we already have, which is customers consuming content and what that content is about, we can use that to optimally design our products. Here's another really cool one. Obviously, I assume everybody in this room knows who American Express is. Now, does everybody here know the term before FICO score? It's basically your credit score that's based on your purchasing history or repayment history, etc. I don't know if you know this, but for every person in this room, American Express is now scraping all your data from social media, Twitter, Facebook, Google+, all social media outlets you use, they're scraping it, and they're adding it to your transaction histories to try to predict whether you're going to churn. For example, I'm pretty sure if I was to stand here today or after my talk and tweet, I'm broke, I've just lost my job, I'm pretty sure if they're smart, American Express should send me a notification decreasing my credit limit. No, I know you're laughing, but it's not funny. It's real money. This is absolutely what American Express can do today. You know what? You know why? Because they've realized that social media data is predictive of customer default and customer churn. They can scrape that data for free. They can add it to the credit score data they already buy from Experian. They can come up with better predictive models about what you're going to do. And now all of a sudden, they're smarter in who they lend money to and who they give credit cards or charge cards to. The next one, Starbucks. I actually walked past a Starbucks. I hate to admit, I love Starbucks, but the fact that it was right across the street from the British Museum turned my stomach a little bit. But either way, I passed Starbucks as I was walking past the British Museum today. Starbucks has figured it out. They figured out the magic of better data. They have a customer loyalty program, either through your phone, card, etc. Do you know that if you're a loyal customer at Starbucks, you don't get discounts? I'm going to repeat that. I did not say it wrong because of the pressure of being up here. If you're a loyal customer at Starbucks, you do not get discounts. Can someone tell me why that's the right thing to do? You should not give discounts to your most loyal customers. Why? They're going to buy anyway. All you're doing is giving away margin. The customers for whom you should give a discount are the ones that are quasi-loyal, right on the fence that you can turn from somewhat loyal to very loyal. Or in mathematical terms, you give customers a discount based on the change in their customer lifetime value as a function of the discount. Not the customer lifetime value, the change in the customer lifetime value you get as a discount. And Starbucks has now recognized this. Why should I give money away to loyal customers who are going to buy anyway? But again, the only reason Starbucks can do this is, has anybody here have a Starbucks loyalty card? Every time you go into Starbucks, you're begging to tell them, have you scanned my card? Have you scanned my card? You think about the favor you're doing Starbucks. You're allowing them to track you. You're begging Starbucks. I think you might have forgotten to scan my card. No, we got your card, Mr. Bradlow. We got it already. I want them to know it's me. Well, isn't that what we all want? We want to understand the customer. The only way you can do that is by data tracking. Starbucks is brilliant. I'm giving them my data. They should be paying me for my loyalty card data, right? The last one, my favorite one, Amazon. Now, I don't literally mean ship before you buy, but I do. Did anybody here in the United States, Amazon just about a month ago came out with an announcement that for 1 million SKUs, if you order it by noon, you will have it at 10 p.m. that day. Could you imagine how much you would pay for that service? Amazon can. Does anybody want to know, anybody have a guess? How does Amazon do that? How do they deliver 1 million SKUs within a day? They know for every customer on Amazon exactly what you've done in the past. That's better data. They're going to build a predictive model, and they're not going to ship it to your home because that'd be a little creepy, but they're going to ship it to a local store near your home so that when you order it, they can give it to you in a day. That is absolutely brilliant. It's called predictive shipping. And again, it's not about bigger data, it's about better data. They have this data so they can predict what you're going to do and they can monetize it immediately. It's absolutely brilliant. For anybody that's an Amazon Prime, imagine how much they're going to charge you for this. It's brilliant. And you'll be thanking them. You'll be thanking them for doing it. Okay, so let me wrap up and say, in 2016, if you think about a data set as rows being the people, and columns being better data, always remember, it's about the columns, not the rows. Because if you have a ton of rows, you should sample it, get rid of old data. It's always about having better columns and better data. That's the key. So if you want to think about it, here's my roadmap. Technology has changed the face of marketing. We all have data tracking devices in our pockets and in our homes. So this dream I had when I started as an assistant professor 20 years ago, that I'd be getting these wonderful data sets where I could track customers over time, that was a dream 20 years ago. Thank God I was young then, because I'm still feeling pretty good, and I'm pretty sure I can now do something with this data, but it didn't exist 20 years ago. This allows you to compute customer lifetime value at the individual level, which means you can now rank order customers, not products, customers in terms of how valuable they are to you. Then, this is where the magic comes in. Now you start ranking customers, firing customers, and you start thinking about customer lifetime value, not cost per acquisition. Because cost per acquisition doesn't tell me anything about the future value of the customer. It's customer lifetime value that matters. So I could go on for hours, as you could tell. I'm actually sad that this is my last slide, because I'd like to keep talking. But I'll be here during the breaks, and thank you for your attention.